Someone once said, "Beauty is in the eye of the beholder." We could say the same things about the color green and its meaning on the radar display. The fact is, depending on your manual operating techniques, green may mean very different things to different pilots. For instance, in low reflectivity environments, some flight crews use a low tilt setting and max gain, and then avoid all weather that paints yellow or red, under the assumption that the threat reaches to their altitude. In these instances, when auto paints the cell green, the crews consider that the radar is under warning. However, other crews in low reflectivity environments use a moderately low tilt setting and calibrated gain. In these cases, most thunderstorm cores paint green on the display, and these cores are considered a substantial threat. When Multiscan paints the core red, as in this picture, and the edges of the cell are displayed as yellow and green, these crews consider the radar to be overwarning. The fact of the matter is that because Multiscan uses variable temperature-based gain, and because geographic weather correlation causes the radar to be far more sensitive in low reflectivity environments, most flight crews will see more than they are used to seeing. This series of pictures is taken over the Gulf of Thailand. Note that in manual mode, in calibrated gain, with a -2 down tilt, only thunderstorm cores are shown. When manual max gain is selected, the weather ridge line is visible to the flight crews. However, because the Gulf of Thailand is a low reflectivity environment, auto cal gain actually shows more of the storm than manual max gain does. With the radar in auto, Multiscan is painting the full extent of the cells. Cores are yellow. Green is normally not associated with severe turbulence unless it is in proximity to strong convective activity. If you believe the radar is showing too little, we encourage you to experiment with what is being displayed. In this case, when the crew penetrated the green area, they experienced light to moderate chop. For crews that believe the radar is showing too much, we encourage you to experiment as well. The true extent of the storm is now visible, so flight paths that transit closer to the cell core are acceptable. Increase in green returns will also occur as weather nears the aircraft. By way of explanation, you need to understand radar beam attenuation. When a radar pulse leaves the aircraft, some of it is scattered and absorbed into the atmosphere. This attenuation of the pulse grows in magnitude as the distance of the pulse from the aircraft increases. In addition, beyond 80 nautical miles, thunderstorms no longer fill the beam, and further attenuation occurs because there is less power on target. This means that at long range, the radar will only be able to see very strong weather, such as thunderstorm cores. As these storms approach the aircraft, more of the cell is visible. In these pictures, note how the radar sees the line of cells at 300 nautical miles. As the cells approach the aircraft, attenuation is lessened, and more of the full extent of the storm becomes visible to the radar. What this means is that it is not unusual for storm cells to fill in as they approach the aircraft. In fact, due to features such as geographic weather correlation and automatic temperature-based gain, the radar now sees more of the actual extent of the storm than could be seen with older radars. Note in this picture how the storm fills in as it approaches the aircraft, and the attenuation of the radar beam decreases. There may be occasions where a transit corridor between two cells fills with green as the aircraft approaches it due to the decrease in attenuation. The Multiscan overflight feature is designed to further lessen the likelihood of inadvertent thunderstorm top penetration. Notice how this cell gradually diminishes and disappears from the display as the aircraft approaches it. This is typical for cells whose tops are at or near the aircraft flight level. Overflight protection uses a combination of lower beam information and computer memory to keep the cell top in view until it passes behind the aircraft. Notice how this low reflectivity cell over the Central Pacific stays on the display until it is no longer a threat. Under certain circumstances, a nuisance blooming effect may be displayed that is a result of the overflight feature picking up and amplifying weather below the flight path. As can be seen in this video, the effect occurs approximately 7 miles from the nose of the aircraft. In this case, the aircraft is experiencing stratiform conditions, and the blooming effect moves with and stays just in front of the aircraft. In stratiform rain conditions, the blooming effect may be ignored. In this video, the radar has detected convective activity below the aircraft, and at 7 miles, the weather return blooms across the flight path. Thunderstorm cells that are below the aircraft and not detectable by radar can grow as rapidly as 6,000 feet per minute, and there are occasions when a rapidly growing cell may be growing into the aircraft flight path. If the return blooms to yellow or red, this is a potential indication of a rapidly growing cell, and turbulence is possible. Future software upgrades will provide earlier warning of these growing cells and the turbulence related to them. In summary, Multiscan has been designed to provide a consistent worldwide weather display, but you may need to reinterpret the color green based on your previous manual operating techniques. Further, as the aircraft approaches a cell and attenuation decreases, more of the cell will become visible.